Welcome to Connected Neurons and welcome to the first episode of this series about trigonometry, which is a topic that we are often scared about when we see it for the first time, probably in high school, because everything looks so new and different to what we are used to. But there's nothing to worry about really. In this course or this series, we are going to be looking at everything related to trigonometry from the very basics like triangles and angles, like this video where we are going to be talking about radians, and then we will start looking at the trigonometric functions and finally waves, which are very related to these trigonometric functions, and not everybody realizes this. But the most important thing is that everybody can follow this course, and it is not so hard, you will see, especially if you go to the link that is in the description, which takes you to my webpage where you have summaries, activities, and most importantly, problems, which are challenging, yes, but they will help you understand everything and what it's used for. But well, let's start with today's lesson. We are going to be learning about radians, which are another way of measuring angles, because right now we do this using degrees. So if we measure angles in our circle, our circumference, which is something we are going to do very often throughout this course, we would have to divide it into 360 parts, and each one of these is 1 degree. But why 360 parts? We could, for example, divide it into 400. Yes, and this, in fact, does exist. But radians are a more natural way of measuring angles, you will see it. And besides, very often when we look at formulas that are related to angles, if they do not have units, they are almost certainly in radians, because they simplify many formulas. But what is a radian? Well, we're going to look at what is the radius of a circle, which of course you probably already know. It is from the center to any point of the circumference. And because it is a circle, it doesn't matter which point you choose, because the radius is always going to be the same. And as you can see, radius and radians are very similar words because they are related. If you took the radius and placed it right next to the circle here, to the circumference, and you started bending it without stretching it, and it fitted perfectly in the arc that is formed by our angle, then this means it is an angle of 1 radian. And although the symbol for radians is this one, we normally don't use the unit. Why? Because let's look at the formula. Our angle in radians, which we can call whatever we like to, but I'm going to call it theta, which is a Greek letter, is equal to the length of the arc that is formed by our angle, so this, divided by the length of the radius. And as they are both lengths, we can, for example, express them in meters, and we divide meters by meters, so in the end we do not have any units when we are measuring our angles in radians. And this is clearly one advantage of using radians, and we are going to check that this formula works. Here the arc length would be equal to, for example, 5 meters. And if the radius is also 5 meters, then this means we have an angle of 1 radian. And how would an angle of 2 radians be, for example? Well, we know that we have to fit 2 radii, which is the plural of radius, not radiuses, radii. And well, this is an approximation, but we start bending it, and also a very informal way of doing it, but it works for starting to learn what radians are. And maybe it would be somewhere over here. This is our 2 radian angle, and we can do this for any angle, and we can indeed verify that this is still consistent with our formula. So our angle, which we said was going to be double the one we saw before, so 2 radians, 2 equals our arc length over the length of the radius, which is the same as before because we have the same circle, so over 5 meters. So if we solve for s, we will find that s equals 10 meters, twice the length of the radius, because we have an angle of 2 radians. However, when we are dealing with radians, we often see angles that involve the number pi, which is very intimidating because it is an irrational number. It has infinite decimals. It is 3.1415926, etc. And this is intimidating, as I said. But where does it come from? Maybe if we know this, then it will be easy. And it is indeed. To find where pi comes from, I'm going to ask you the following question, and you should try to figure it out yourself. See if you can. Taking into account the formula for the circumference of a circle, so you remember the area was pi r squared, and the circumference was 2 pi r. What do you think is the angle in radians of the whole circumference? So of this angle, our angle theta was equal to the arc length over the radius. So the arc length in this case we know is 2 pi radius. So then the angle is 2 pi radians, and it makes sense because we can fit 2 pi radius, that's the length of the whole circumference. So if we bend it, we have 2 pi times the radius, and we do the whole lap around the circumference. So from here we can get basically all of the angles we want. What do you think is an angle of 180 degrees? Well, it is half 2 pi radians, so pi radians, and this, as we said, is 2 pi. And what do you think is an angle of 90 degrees? It would be half pi radians, so pi over 2. We'll leave it as a fraction because if not, we would have to make an approximation. Remember that pi was an irrational number. And finally, 270 degrees would be, by same logic, 3 over 2 pi, or 3 pi over 2. So what about 200 degrees? What is that in radians? How do we convert from degrees to radians? Well, we can use a conversion factor. So you know that if we multiply 200 degrees by 1, we get 200 degrees, and 1 would be equal to, for example, 2 over 2, because we have the same number in the numerator and the denominator. So this is still 200. What two values do we know are equal that could be useful for this? Well, we know that pi radians is equal to 180 degrees, or you can use anything you know. 2 pi radians is 360 degrees or whatever. And then you go to the calculator because degrees cancel out with degrees, and 200 times pi over 180 is 10 over 9 pi radians. And we can do the opposite to go from radians to degrees. This time, as we want the radians to cancel out with the radians, we would put 180 degrees in the numerator, and in the denominator we would put pi, and we would get 200 degrees. And that's basically all there is to know about radians. It's just another way of measuring angles. Although there is one more thing I would like to tell you. Remember I said that with radians many formulas that involve angles are much simpler and look better in general. So for example, let's take a look at Euler's identity, which is considered the most beautiful equation in all of mathematics. So we have E, which is another irrational number, which is used very often in mathematics, to the pi I, and I is another number that is going to be very important when you start learning about imaginary and complex numbers. It is equal to the square root of -1. Don't worry about this, it's not important right now, but it's just to show you that radians make formulas more beautiful, because this is equal to -1, and if you don't think this is beautiful, I don't know what is. We have these relationships between these crazy numbers, and we get -1, and if we expressed this pi in degrees, e to the 180 degrees I equals -1 is not as beautiful, is it? As we can see, we cannot use radians and degrees interchangeably. So when we are using the calculator, we want to make sure we have the right settings and see that the default unit for angles is set to the one we want to use, because e to the pi I is not the same as e to the 180 times I, because pi is not equal to 180. Pi radians equals 180 degrees. And also, if you have any formula that involves angles, if you do it in degrees, normally it is going to become very messy. You would have to incorporate the conversion factor we used before into the formula, and it's very messy. So that's why you want to use radians. Well, I hope you understood it. As I'm always going to say, you can go to my webpage, which is in the description, to practice with some problems, and you will understand everything perfectly. So I'll see you in the next video. Bye!